Many people are always seeking ways to improve their health and to live longer. And in the past few years, intermittent fasting has become a really popular approach to that. So, what is intermittent fasting and how does it work? Intermittent fasting is a diet in which one alternates between feeding and fasting periods. Popular periods include 16 hours fasting, 8 hours eating, and also 20 hours fasting, 4 hours eating. The diet does not necessitate tracking how much or the composition of what you're eating. It just requires that you stick to the fed and the fasted states. As seen in animal studies, intermittent fasting has many benefits. In addition to weight loss, it lowers the risk of cardiovascular disease, type 2 diabetes, can help people reach target numbers for blood pressure, cholesterol, and triglycerides. It decreases oxidative stress, increases cellular repair, and decreases inflammation. And additionally, it's been shown to extend lifespan in bacteria, yeast, roundworms, and mice. Of course, intermittent fasting isn't perfect, but what are some of the ways it works and some of the challenges that come with it?
Let's explore the challenges of intermittent fasting that people often face. First, there's consistency. Adhering strictly to caloric restriction can be tough, impacting quality of life and making it challenging to maintain this diet over a long term. Next, we have sufficient nutrients. With restricted eating windows, ensuring you receive all necessary nutrients each day becomes a challenge. This is crucial because nutrient deficiencies can lead to various health issues. And lastly, variability. Individual responses to intermittent fasting can differ significantly across the person. Each person's metabolism reacts different, which means the effectiveness and side effects of fasting can vary. Understanding these challenges is key for anyone considering or currently practicing intermittent fasting. To get a quick overview on the insulin IGF signaling pathway, the process begins with the hormones insulin and IGF-1 binding to their receptors. This binding triggers a cascade of signals responsible for regulating everything from cell growth to lifespan, a pathway that is universally observed across our model organisms. Next, the insulin receptor activates PI3 kinase, a critical signaling enzyme that sets off a series of downstream effects crucial for cellular functions. Activated PI3 kinase then activates AKT, which in turn directs the activity of TOR-C1. This complex is pivotal in regulating cell growth through its control over protein synthesis and metabolic processes. In conditions rich in nutrients, we observe that this pathway promotes vigorous growth and energy utilization. In contrast, during times of nutrient scarcity, such as what occurs during intermittent fasting, there's a noticeable decrease in AKT activity. This reduction causes the cell to shift its priorities, slowing down growth and ramping up autophagy, a process that helps cells conserve resources during times of stress. Additionally, a decrease in AKT activity leads to an increase in the activity of phosphotranscription factors. These factors move into the nucleus and activate genes that enhance cellular defenses and longevity, a key mechanism if our goal is to extend health span across different species. Through intermittent fasting, we artificially reduce our access to nutrients, mimicking the conditions necessary for reduced insulin signaling. This not only helps conserve energy, but also activates pathways for repair and longevity, potentially enhancing our health and lifespan. By studying this pathway across various model organisms, we gain invaluable insights into fundamental biological processes that could shape the future of medicine and research.
The first study we analyzed concerning intermittent fasting was the alternate day fasting. Improves physiological and molecular markers of aging in healthy, non-obese humans. And this was done by Hofer-Stakovich and others, where we got this graphic. And alternate day fasting is when participants would eat every other day. And this was seen to have about a 28 to 37% caloric restriction, which means it's about a quarter less food than they would eat in a day overall. And it was thought to be a more sustainable long-term way of getting caloric restriction, which would therefore increase the anti-aging benefits. And it was seen to have increased various cardiovascular biomarkers and other inflammatory responses. Also just decreased body fat and increased cardiac health. So it seemed to have a positive effect. The only caveat, what we said, was the study only consisted over 6 months and had a varying level of caloric restriction, which means it could impact people differently, and varying level of caloric restriction would result in different effects. The second study we analyzed concerning intermittent fasting was a periodic diet that mimics fasting, promotes multi-system regeneration, enhanced cognitive performance and health span. And this was done by Choi Brandhorst and others. In this study, the researchers wanted to see how different organisms would respond to periodic fasting or periodic fasting mimicking diet, which would be something like intermittent fasting. And we saw that the biggest similarity they all had was that it impacted their inflammatory response. And for yeast, this looked like better stress resistance and an increased lifespan. For mice, it looked like various increased resistance to diseases such as cancer and other cognitive diseases, and it's also resulted in an increase of lifespan. And for humans, while there was a seemingly decrease in cancer and diabetes from this inflammatory response, there was no increase of lifespan or health span. And this is why one of our caveats was, despite the fact that there was no increase to lifespan or health span or decrease in risk of chronic diseases, the study claimed that there was a decrease in aging despite these facts. So that was the only caveat to this study.
So, does intermittent fasting work? It's shown promising effects in model organisms, but is yet to be recreated in humans with the same level of success. This can be due to the diet's low retention rate, which makes it an unlikely long-term intervention for longevity. It can also be dangerous to upkeep. If you are intermittent fasting, you should always consult a medical professional. However, the diet could be useful in pre-diabetic individuals as it may reduce the incidence and mortality of diabetes and cardiovascular disease. To see the effects of intermittent fasting, the diet must be strictly adhered to or the effects are reversed. So, although the diet could be promising, the difficulty of sticking to the diet make it an impractical long-term intervention for aging.